Hi and welcome to the Neil Ashton podcast. In each episode, we explain some of the fascinating ways that science and engineering are changing the world around us. We talk to leading engineers from elite level sports like cycling and Formula One, to some of the world's top academics to understand how fluid dynamics, machine learning, supercomputing are bringing in a new era of discovery. We also hear some of their life stories, their career advice, and lessons they've learned on the way that I hope will be helpful to you too. So sit back and enjoy this episode. Hi and welcome back to the Neil Ashton podcast. So today I wanted to talk about the topic of foundational models for fluids or for computational fluid dynamics. It's a topic that I brought up and asked quite a few of the people that I interviewed recently, but I wanted to give some personal thoughts on this, partially because I had the pleasure a couple of weeks ago of chairing a panel discussion at the second data-driven fluid dynamics conference, which was an COFTAC Euromech thing that was done at Imperial College London. I was involved in the first one in Paris the previous year, and it's a great initiative that has tried to bring the fluids community and I guess the AI community together, particularly with a sort of European flavour, I guess, to it. But in this panel session, it was really interesting because we had representatives from, Harvard, but also Caltech and some from industry and really representing the experimental and the computational side. And one of the things that I did was to try and ask people about their opinion of foundational models. But more interestingly, or as interesting, was I tried to ask the audience some of the questions. And there was a couple of hundred people in the audience. And so we use this Mentimeter app that I have to confess I haven't really used before, but it's great because you can essentially do real-time polling of people. So I asked the question, do you believe that we will have foundational models? And in fact, I'm just looking on the screen now because I have the results up. Well, I should tell you, the first thing I did ask was, what's your favourite British food? A bit of a tongue-in-cheek, really, and people thought fish and chips won, followed secondly by the vomit emoji, which I was a bit offended by, and then full English breakfast. So there we go. But more seriously, on the actual topic of foundational models, I basically said, can we get a foundational model for fluids? How generalizable could it be? And what I asked was, could this foundational model provide instantaneous pressure velocity for any boundary condition or geometry? So as in, you can say to it, here's a geometry with a certain boundary condition, can it predict it and give you the instantaneous pressure and velocity? A bit like a CFD solver. Now you give it a geometry, you give it some boundary conditions, and it will go and solve it. The second option I gave people is exactly the same, but time averaged. So not instantaneous, but time averaged, and I'll get into the nuance of that in a little bit. Then the third option was yes, but only for a specific use case, as in maybe like a road car or a plane. And finally, the option was essentially no. Fluids are just too complex for an AI model to learn. And interestingly, out of the scores, it was 38. I think this is out of 100 and something. So the most popular answer was only for a specific use case, 38 people. Close second, 37, was provide time averaged for any boundary condition and geometry, followed by instantaneous pressure, and finally 13 had fluids that are just too complex. So out of that audience, which is biased because they are researchers looking at fluids and AI, the sense was it really is only possible for a specific use case, and therefore the terminology of foundational model is perhaps pushing it a little bit or needs redefining. Okay, so that's why essentially I wanted to talk about it. And I wanted to share, I guess, some opinions of my own, some stuff I've seen along the way. I'm in a lucky position, I guess, working in the tech sector, that I get to engage with a lot of customers and academics from different groups. So I'd like to and go to conferences, and I'd like to say I therefore have a reasonable good view of what's going on in the community. And I would actually say that things are looking very interesting, as in only a couple of years ago, there was really no work into this idea of a foundational model. And another way of thinking of foundational model is simply a pre-trained model. So what most people were looking at was simply, can we come up with some sort of algorithm, some architecture that could allow somebody to go and train an AI model based on prior simulation data? So we're not talking about accelerating an existing code, we're talking about replacing the code with a surrogate model. And that was certainly the main focus probably 5 years ago or 4 years ago. And there was some seminal work done with things like Mesh GraphNet and others, which took a graph neural net approach where you could essentially take the nodes of a mesh as the input. And that was something, or particles, I guess, because there was all the particle examples of this. And this rapidly became one of the success stories in the weather and climate, but also was showing potential for CFD. And this led to a number of startups that formed over the time, these sort of Navistos, Neuroconcepts and others, who took some of these work or pioneered things themselves and released some of those things that people could go and try for themselves. And so you saw in the past, several years, people really wanting to test out those methods, and with some success for sure. But obviously that requires you to have your own training data, your own ability to train a model, and to have, I guess, both the software and the knowledge to do it. And I guess if you can compare that against what you would typically see in the LLM space, where majority of us are not training our own LLMs, but we are simply doing a prompt and asking it a question, doing an inference. We're not training it. The logical question was, well, could it be possible to train a model and then just provide it to people as a pre-trained model? And it's a really interesting discussion because it has pretty large, it could have a potentially very large impact on the CFD community. Now, there are some of you out there who still have very negative opinions of AI and sort of see it as a fad and it will come and go. But I would say those voices are slowly starting to be overtaken by the realization that actually these methods have a lot of potential. Only, like I said, 5 years ago, this was basically not happening. Nobody was even talking about it. I remember I got involved maybe 3 years ago in this topic, so still quite late to the game, I guess. But even 3 years ago, I remember most people had no idea what this was all about. They just thought of this as like reduced order modeling, ROMs, real no sense of what was going on, didn't know what architectures would work. There was only maybe 1 or 2 startups in the space, wasn't very prominent. Fast forward to now, and I would say that it is certainly rapidly expanding. And I would say companies can be categorized as either trying to lead in this way, being very interested, and the number who are just set against it is now sort of getting lower. But I would say that this is still a little bit split between the industries. And there's a bit of a parallel with high fidelity methods. I see the automotive sector has been much faster to adopt these new technologies or investigate these new technologies. Automotive companies today use sort of hybrid around scale resolving methods on a day-to-day basis, whereas the aerospace sector is still sort of proving out that they think they can be used in production. And some of that is because of Reynolds numbers and complexities, and other is just a mindset, I believe. And interestingly, I see the same thing with the AI. I see that the automotive companies are far more motivated to try and find AI approaches that can be faster potentially, and are embracing it, whereas I see aerospace is more in the mindset of, I don't think this can work for me. And I guess part of the reason doing this podcast episode is really just to put across, and this is this is not influenced by the company I work for. These are all sort of independent opinions, personal thoughts, but I really do think that these are looking incredibly interesting for the obvious reason that now if you do an inference on a model, you're going to get an answer in seconds. But the accuracy is debatable whether people have truly proved out that these AI methods are accurate enough. They give a very good impression of, approximately what the flow field is or approximately what the lift or drag is. But I would say that we are still not at the case where they're widely accepted or there are very clear accuracy. I would say it's a bit like CFD in the early days, where you could argue there was clear points where it worked well, but there were many examples where it didn't work, and hence why CFD took decades, to progress and be trusted enough to be a dominant design tool. I'd say AI is still in that sense where it's probably not trusted as a key design tool yet, but I would say that the number of companies really investing in this is significantly growing. A number of startups who are emerging in this space is growing month on month, and the interest from the big ISVs is also growing month on month. But the challenge is the data. So do you have available data? And this has always been the challenge for the idea of a foundational model. As probably people know, the reason that these LLMs and others can do so well is that they have a very large data source to get to. So typically scraping off the internet, but nowadays maybe doing commercial deals with a certain repository of data. If you want to do something on journal papers, you might do a deal with Elsevier or John Wiley. If you want to do something on video, you might do a deal with a video, distributor, or a newspaper. If you want to do on text or pictures, you might do it with Adobe. There's a lot of commercial arrangements going on now. And I think that's what's super interesting on the CFD side, because on one side, you could say the data is just not available. If you want to do combustion modeling or multi-phase or hypersonic something, this is not publicly available data. So how do you solve that? And this is where I think there's an interesting technical but also commercial angle to this, which is it worth it for a company to independently run lots and lots of simulations to the fact that they can pre-train a model and then supply that model and charge it at a certain rate? And we have seen some early signs of this happening. There's a startup, Luminary Cloud. Some people know that I spoke to Juan Alonso, the founder, and they recently released a sort of foundational model for road cars, where they'd run a whole bunch of simulations themselves in collaboration with an end customer of theirs, and then release that and pre-trained a model. Now that it's probably too early to see, how ultimately successful that will be, but they've sort of fired the starting gun, so to speak, on an actual company releasing a sort of pre-trained model, and I think it's really interesting to observe how useful that is, because on one side it removes a massive barrier for a company to collect all the data, find all the data, have the expertise to use an AI tool. It's much easier just to do inference on a pre-trained model. So I think that's the first thing. I predict that we're going to see many more of those come out. Many more companies will do that, both, I think, from a startup and an ISV space. But how much data can a company generate, and how can they incentivize it? Well, one interesting thing, when I spoke with Prif, who's the CTO of Ansys, he said in one of the talks that I gave that, maybe the ISV needs to incentivize people to allow the ISV to have the data. So I think that's a really interesting proposition that, what if you would tick a box that was to say, well, as you run your CFD simulation, I give permission for the ISV to use that data, and perhaps in return they get some commercial incentive to do it. And I think that's a really interesting proposition, and I'm keen to see if some of the ISVs go down that route. And this actually links why I've often spoken about the cloud being an important avenue. And the cloud being an important avenue links to this because of the SaaS bit. If you give somebody a on-prem binary, even if they tick some box to say we're happy for you to look at our data, what's the mechanism to share that file? Well, it's pretty difficult because it's running on their local network. How are they going to, send that over to you? It's not practical. Where with a SaaS solution, it's much easier because it's by definition running in, let's say, someone's cloud. And so if you say, I want to share some of my data with them, it's actually much easier to do it. So I predict that part of the motivation, and I think we'll see an acceleration of the SaaSification, is to make this sort of AI and data collection easier. Both if you're an existing AI startup, you could say, hey, use my AI tool and I'll give you a discount if you share your training data with me, and over time we'll collect more data. And also it links into one of the things I've said repeatedly on this podcast about fast CFD solvers or CAE solvers. Because now one of the big things is if you've got to generate 5,000 CFD cases, if your CFD solver is twice as fast as another CFD solver, that's a big amount of money to save. Or for the same budget, you could run twice as many cases. So if we assume that people to build these foundational models will have to run hundreds of thousands of cases, then actually there will be a huge focus on enabling the code to be as efficient as possible. Now, one of the other things that I haven't brought up, but I think is another interesting one, is everything I've spoken about now assumes that the CFD code is independent from the AI code. But as anybody knows anything about, for example, in situ visualization, will know that there's a strong move now towards this idea of doing it, online, rather than saving everything to disk and then doing the visualization. Can you do it whilst it's running? And this is obviously something, it's not just me, saying this for the first time, it's known that I think there'll be a big increase, and there already is, certainly in the academic world, of trying to build your CFD code in the same framework as your AI code. Some groups are doing this in PyTorch, how do I write a code in there? Or they're using some sort of Python code that you can automatically, differentiate and move between to pass gradients along and to the neural networks. But I predict this will be important because if you are trying to build some pre-trained model, some sort of foundational model, you don't really want to be doing your CFD independently to your AI training. You want them to be tightly coupled and potentially adding more points as you need them, and not having to be, bound by I/O issues, having to keep the data, which is particularly true if you have the dream, and I think this is a much longer term dream, of being able to do instantaneous, so time dependent. Most training now is done on time average solutions, even if it's a time accurate simulation, because just the amount of data. I mean, having created with colleagues, the driver ML data set, it's already 30 terabytes with one time step, essentially, as in the time averaging. If you were going to try and do it for all of them, 200,000 iterations, well, you can do the maths. It's unbelievably large. But if at every time we were running those simulations, we were passing that data to a model to train, then the cost, we don't need to save the time steps out. We're just passing it in memory. So we actually could have done it because we were running the simulations time dependent anyway. So I think this is where there's a lot of interest in these. I feel this is where new technologies are converging with AI as the sort of motivating factor. So foundational models, I really would encourage any academic who's listening to this. I think this is the topic to propose as a big university project or European project or government project or, anything that is big, because if this could be made, and there's so many debates on should it be open source, should it be closed source, it could transform the way that we are doing CFD today. If it is possible, it would change the commercial landscape, it would change the technical landscape. And if you imagine that it's possible for a certain class of applications, you've got to imagine the transfer learning, the fine-tuning. At some point, how different is a car than a plane or a city if you are starting with, if the model is able to learn some of these interactions? I haven't really spoken about the idea of including physics into it, but I really do feel that just as 5 years ago AI was an interesting thing for people to look at, I think the whole concept of foundational models is becoming interesting. I believe at the beginning it will be for specific use cases as the audience voted, but I perceive that there will be a bit of an arms race between the ISVs and startups to build this. And it'll be interesting to see whether companies see this as their secret sauce. Whether, an aerospace manufacturer or an automotive manufacturer says, well, I don't need the ISV. I'm going to do it myself. And this will be an interesting balance between the software suppliers, the companies, because on the other hand, the automotive company can say, well, we're not a software, we're a car designer. Why are we going to write our own codes? And that's certainly been the case. Even in the aerospace, there's a move towards commercial codes. It used to be the case everybody would write their own codes and that was their IP. And then they realized their IP is making cars or planes, not writing software. So I still suspect that most of this work, these foundational models, will still make their way into commercial sort of big software companies, ISVs. But given that they don't have the data, it's the sort of engineering companies who have the data, and they need to somehow get that data or produce that data. There'll be an interesting dynamic, I think, in collaboration. So these are just my personal thoughts. I could be completely wrong, but I am quite bullish on the idea of some of these foundational models. And certainly, in my day job, this is something I'm actively pursuing. I'm academically interested. I'm interested in, NVIDIA doing its bit to help things along the way. I'll be really interested to see what happens in a few years' time. So maybe I'll try and set a reminder in 2 years to record another one and see how much of this I was right on. And maybe it'll all not happen and I was completely wrong. But I'm going to make a bet that in a couple of years we will have progressed quite a bit further than we have done to date. So with that, thanks for listening. I would really enjoy your comments. Let me know what you think. If I'm completely wrong, if you have a different viewpoint on it, please put your comments in the YouTube or send me a message. And thanks for listening and hope you enjoyed it.